You are welcome to another episode of our weekly online chemistry class. In the last episode, we talked about the basic organic reactions that we have, which are addition, elimination, substitution, and rearrangement. And I told you during that class that we have other types of organic reactions, but they fall under these four basic types. Today, we are going to discuss bond breaking and the types that we have. In an organic reaction, for any reaction to take place, there must be bond breaking from the reactant and there must be bond formation to the product. So when we say bond breaking, it's the breaking of bond between two atoms or group of atoms in a molecule. And these bond cleavages of fission is of two types. We have homolytic cleavage and we have heterolytic cleavage or fission. Now, homolytic bond fission is the breaking of bond between two atoms or group of atoms of the same or similar electronegativity values to form free radicals. Take for instance, when you have atoms X or group of atom X combining together with a single covalent bond. This covalent bond is formed when each of X donated one electron. And for the bond to be broken, that means each of the atom or group of atoms X must share the bonding electrons equally. And when that occurs, there is going to be formation of a species with odd number of electrons. And that species is known as free radicals. So we have X free radical and X free radical here. Typical examples of free radicals are, you have free radical formation. You have, look at this, hydrogen molecule. The bond between these two hydrogen, for it to be broken, both hydrogen atoms will share the bonding electron equally to give us odd number of electron species. So that means a chemical species with odd number of electrons is what we refer to as a free radical. Another example, look at bromine. A bromine atom has 7 electrons in atomic shell, and that is why it is classified in group 17 of the periodic table. So when each of them donated 1 electron to form this single covalent bond, left on each atom is 3 lone pairs, which amount to a total of 6 electrons. Now when the bond is broken, you are going to form a bromine free radical. Bromine free radicals. If you count the number of electrons on each bromine atom, you are going to count 7, which is odd number, and that's what makes it to be a free radical. Another example, look at the hydrogen peroxide. When the bond between the two oxygen atoms is broken, you are going to form hydroxyl radical. Another example is ethane. Breaking the bond between the two carbon atoms, you are going to form 2 molecules of methyl radical. Methyl radical. Now, free radical reactions usually take place in non-polar medium, and they mostly exist in gaseous medium. And some of the reactions undergo by free radicals are: 1, we have combination, free radical combination reaction. In this, 2 free radicals combine together to form a neutral molecule. That is 2 methyl radicals to give you ethane. We also have radical transfer. Radical transfer, whereby a free radical, look at chlorine radical, combining with methane to give us methyl radical and HCl. The free radical has been transferred from chlorine radical to the carbon atom of methane to give us methyl radical and a neutral molecule. Then we have disproportionation. Disproportionation reaction. In this reaction, you have a free radical, let's say for instance, propyl radical, giving us a methyl radical and ethene. So the molecule has deproportionated to give us ethene and methyl radical. Then we have free radical addition, whereby two free radicals, let's say for instance chlorine radical combining with methyl radical to give us a neutral molecule. Okay, that's similar to combination. Okay. Addition. A chlorine radical combining with neutral molecule. Okay, let me use 18 to give us chloroethyl radical. Look at the difference between this addition and combination. So these are some of the reactions that is quite common to free radical chemical species. The other type of bond cleavage is what we refer to as heterolytic fission or breaking. Heterolytic cleavage is the breaking of bond between two atoms or group of atoms of different electronegativity values, resulting to the formation of ions of opposite charges. That is positive charged ion and negatively charged ions. Take for instance, if you have atom X combining with Y, assuming Y is more electronegative than X, there is going to be formation of all the bonding electrons will be attracted towards Y away from X. So X will be deficient of electron, while Y will be electron rich. So any chemical species that is electron deficient is what we refer to as electrophile. Electron lover. So when you say you are hydrophilia, that means you have love for water. Hydrophobia, that is hate for water. Here, any chemical species that is electron rich is what we refer to as nucleophile. Nucleophile means nucleus lover. Remember, the nucleus of an atom is positively charged. So anything that is in love with positively charged species is what we refer to as a nucleophile. So these are the other two types of organic reagents that we have. So by definition, an electrophile is a chemical species that is electron deficient and attract electron rich species in an organic reaction. So they are electron lover, and we have many of such. Typical examples are hydrogen chloride. When the bond is broken, you are going to form hydrogen ion and chloride ion. So hydrogen ion is an example of an electrophile. Other electrophile example, we have plutonium ion, you have alkyl carbonium ion, you have bromonium ion, you have nitronium ion, among others. While other examples of nucleophiles, we have bromide ion, chloride ion, hydroxide ion, hydride ion, alkyl carbanion, or carbanion to be precise. So, and don't forget that nucleophiles can either be neutral or negatively charged. Although we have some electrophiles that are also neutral. Take for instance the carbonyl group of alkana or alkano. That carbon atom is electrophilic in nature, while the oxygen atom is nucleophilic in nature. Now, nucleophiles, they can either be neutral or negatively charged. These are examples of negatively charged nucleophiles. While examples of neutral nucleophiles are water molecules. They are nucleophilic in nature because they have lone pair of electrons on the central atom. Then you also have ammonia. Then you also have carbon monoxide. That is why nucleophiles are also referred to as ligands or Lewis bases, while electrophiles are also referred to as Lewis acids. So these are the three major types of organic reagents: free radicals, nucleophiles, and electrophile. Free radical reactions, don't forget I told you, takes place in non-polar medium, and most of the reactions usually exist in gaseous states. While electrophilic and nucleophilic reactions usually occurs in aqueous or in polar medium. Now, these three types of organic reagents determines the mechanism of all the basic organic reactions that we have. That is, you can have free radical addition, electrophilic addition, nucleophilic addition. Free radical substitution, electrophilic substitution, nucleophilic substitution. In our subsequent edition, we are going to discuss the mechanism of organic reaction one after the other. But as of today, I believe you have learned one or two things. Do not forget, there are two types of bond cleavages. Do not forget the reagents that are produced from each type of bond cleavages. And you must be able to identify the type of bond cleavages that is peculiar to a particular chemical reaction by mere looking at the nature of the reactant that is involved in that reaction, whether the reactant is polar or non-polar. Do not forget to comment, like, subscribe, and share our video. Thanks for watching. We'll see you again some other time.